Hi, welcome to my video on solving trigonometric equations with the angle as b times theta minus h, and this is part 2. Let's solve the equation, and we have her from 0 less than or equal to theta less than 360. So we're allowed to have a 0, but we're not allowed to have 360. Or again, notice we can't have a negative, or we can't have more than 360. So let's look at the equation. So we'll let cos, we have cos bracket theta minus 30 equals a half. So we'll let theta minus 30 degrees be A. So we have the cos A equals a half. And we have a half, which is a special right triangle. So we have 30, 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. Hypotenuse is 1. So cos is adjacent. So that means that the angle adjacent to 60 to give a half. So A is 60 degrees. Or we could say the reference angle. Let's look at the reference angle. The reference angle is 60, it's positive. The reference angle is 60. Now, look at the quadrants. Add sugar to coffee. And that means we're looking at where cos is the x, cos is positive, and cos is all, so it's quadrant 1. And this is sine, tan, cos, so we got quadrant 4. So we have a reference angle of 60 in the first quadrant. Reference angle in the fourth quadrant, 60 goes here. So the rotation here is that A is 60 degrees. And right here it's from the terminal arm all the way around. So A here is 360 minus 60. So A is 300 degrees. So now we'll let A is theta minus 30 is equal to 60, and we'll add on 360 n, where n belongs to the integers. And over here we'll do the same thing. Theta minus 30 equals 300 degrees plus 360 n, where n belongs to the integers. So let's solve each of these out. So theta equals 60 plus 30. And we'll write down the rest of the statement here. And theta is 90 degrees plus 360 n, where n belongs to the integers. And we'll do the same thing over here, and we'll theta is 300 degrees plus 30, and 360 n belongs to the integers. So theta is 330 degrees plus 360 n, where n belongs to the integers. Now, if we let n be 0, then 90 plus 360 n is 0, so that becomes 90 degrees. If we let n be 1, we get 90 plus 360 times 1, we'll get 450. So 450 is too much because we're only allowed to go between 0 and 360. So theta is 90 degrees when the angle is 60. And let's look at n, and we look at 330 plus 360 n. So n is 0, so we put 0 here, we get 0, so we get a 330. If we put 1 in, we get 330 plus 360 times 1. So that's 690, and that's too large, so that's no good. So theta right here would be, make the theta is 330. So the two answers are 90 and 330. So if we take 90 and sub in the equation here and work it out, you get a half. Put 330 in here, subtract 30, you get 300. The cos of 300 is a half. Okay, let's do another one. Solve, again, 0 less than or equal to theta less than 360 or in degrees. And this time we have sine of 2 theta is a negative root 2 over 2. So that means we'll let 2 theta be a. So we have the sine of a is negative root 2 over 2. This is negative, so we'll do the sine of the reference angle. Make it positive. And we have root 2 over 2, so that's a 45, 1, root 2 over 2, root 2 over 2, special right triangle. So that means the reference angle is, no matter which one you use, you get sine is opposite over hypotenuse, cos is adjacent over either one, you get a reference angle of 45 degrees. And we add sugar to coffee, and sine is negative, so sine is positive in 1 and 2, so it's negative in 3 and 4, or sine is the y is negative down here, so we have third quadrant and a fourth quadrant angle, third quadrant, fourth quadrant, 45 reference, rotation is right to here, so A is 180 plus 45, so 180 to here, 45 more, so that's 225, and a rotation here to the fourth quadrant all the way around, so A is 360 minus the reference of 45, so that's 315. So we'll let 2 theta is A, so 2 theta is equal to 225 plus 360 n, where n belongs to the integers. And for this one, we do the same thing. 2 theta equals 315 plus 360 n, where n belongs to the integers. And now we divide by 2, so theta is equal to, and that's 112.5 degrees, and 2 into 160, or 360 is 180. We got that one done. We divide by 2 here, theta is, and 315 divided by 2 is 157.5, and 360 divided by 2 is 180. And notice it's 180 here now. Notice that B is 2. B is 2, so 180 divided by 2 makes the period 180. So that's why I put the 360 here and then work it through. Now we make n is 0, and we do 112.5 plus 180n. Put 0 in, you get 0, so you get 112 degrees. You put 1 in, you get 112.5. Add on, put a 1 here, you get 180. So that makes it, add on 180, that makes it 190, or 200, sorry, 290, 295, 292.5. I can't add. And if I put 2 in, I get more than that. I get more than 360. So there's the 2 angles here for these two. So for that one you get 112.5 and you get 292.5. So let's work out this one. So n is, and here we got 157.5, add on 180 n. So we put a 0 in, 180 times 0 is 0, so we get 157.5 degrees. Put 1 in, we get 157.5 plus 1 times 180 is 180. So we add that up and we get 337.5. And again, if we put a 2 in here, we get more than what we want. So we put a negative in here, we get a negative angle, and we can't have a negative angle. So these two are 157.5 and 337.5 degrees. I just thought I'd make some questions up a little bit different. And let's try another one that's a little bit different. This time we're solving 0 is less than or equal to theta less than 2 pi. So that means we're in terms of a radian. So this time we'll let a half theta plus pi over 2 equal a. So we have the cos of a is -1. And again, this is the -1, cos is the x, so that's right here. So that means that we get, in terms of 1, -1 and 0, we don't have a reference angle. So that means that A is 180 degrees. Now I do degrees, and then I change degrees to radians. So 180 times pi over 180, they cancel. So A in terms of radiant is pi. So I work it out in degrees and then change degrees to radians. Much easier. I find it easier to do it that way. So now we have the angle is a half theta plus pi over 2 equals, and you have a pi. We only got 1 at this time, so it's plus. Instead of having 360 n, we have 2 pi n, where n belongs to the integers. And now we multiply by a half. And we transfer the pi over 4 to the right side and make it negative. We simplify that, and pi over 4, that's pi, so that's 4 pi over 4, so 1 subtract 1/4 is 3/4, so that's 3 pi over 4. And now we have, this is a half, so multiply by 2. 2 times a half is 1. 2 times 3 pi over 4 is 3 pi over 2 when we multiply by 2. And 2 makes it 4 pi n. And we have, again, n belongs, make that integers. And n belongs to the integers, comes down right here. I didn't write it in each one. So we have, these are all the angles that will make this true. And so now that we have that, so we say n is 0. We get 3 pi over 2 plus 4 pi n. N is 0, this is 0, so we get 3 pi over 2. Let's do n is 1. We got 3 pi over 2 plus 4 pi times 1. So that's 3 pi over 2 plus 4 pi. And notice when you add that up, you get an 8. So that's 11 pi over 2. But you can see we're adding on 4 pi. So that makes it way bigger than what we have here. So n can't be 1, so this is the only answer. So the answer, theta, is 3 pi over 2. Okay. And the last page. Again, we have a radian, but I made this one a little bit more, a little bit longer to do some calculations. Let's have a look. We're solving, again, as a radian between 0 and 2 pi, but equal to 0, but not equal to 2 pi. So we'll let the angle equal A. So we have the sine of A is root 3 over 2. And because it's positive, A is already the reference angle. So if we draw the triangle, again, 30 and 60, that's the half. There's the 90. There's the root 3 over 2. That's the 1. And the sine of what angle? So that means that the reference angle is 60 degrees. The sine of 60 is root 3 over 2. So let's continue. We'll add sugar to coffee, and all sine, tan, cos are positive. We want sine to be positive. Sine is positive here and here. Sine is the y. Y is positive up above the x-axis. So we have a quadrant 1 and a quadrant 2. So quadrant 1 and quadrant 2, we put the reference angle of 60 in there. Put the reference angle of 60 there. So the rotation, so A is 60 degrees, and A here is the rotation. So it's 180 minus the 60. So A is 120. So we got the two angles. Let's fill in 3 theta minus pi over 6. That's equal to 60. And we add on, and it's in radians. Oop. Okay, I forgot to do radians. I got degrees. So 60 is pi over 3. Let's see, 60 times pi over 180. 60 cancels in 3. And 120 is just the reference angle. So 120 is 260, so it's 2 pi over 3. So we have to put in, we want a radian, so we got to put in pi over 3 here. That's a pi over 3, and it's in terms of radians. So that's pi over 3. I almost did it in degrees. And for this one, we have 3 theta minus pi over 6 equals 2 pi over 3 and plus 2 pi n, where n belongs to the integers. So this, I'm going to work this one out first all the way down, then work this one out so we won't get confused. So let's go 3 theta. 3 times pi over 6 becomes pi over 2. The 3's cancel. And that's pi over 3 plus 2 pi n. And I'm not going to keep writing this down. That's there. And we'll move 3 theta equals pi over 3 plus pi over 2. Again. And so this is, if you add here, common denominator 6, so that's a 2 pi over 6, common denominator 6, 3, 2 into 6 goes 3, so that's 3 pi over 6. And so we have 3 theta, that's 5 pi over 6 plus 2 pi n. Now we got to divide by 3. Divide by 3, so we get theta is, that's 5 pi over 18, and divide by 3, I get 2 pi over 3 times n. N belongs to the integers. So now let's take our time. N, we got 5 pi over 18 plus 2 pi over 3n. And so when n is 0, this is a 0, so this is a 0, so we get 5 pi over 18. And when n is 1, we get 5 pi over 18 plus 2 pi over 3. N is 1, so we put a 1 here, we get the same thing, so that's 5 pi over 18. 18 is the denominator, so 6 times 3 is 18, 2 times 6 is 12, so that makes it 17 pi over 18. And, oh, I got n there. That should be n is 1. And keep going. Let's see, we'll try a 2. N is 2. So 5 pi over 18 plus 2 pi over 3. Here I multiplied it by 1. And here I multiplied by 2. So I won't put that down. So multiplying by 2, I get 4 pi over 3. And that's 5 pi over 18 plus 18. So multiply by 6 is 24. So that gives us 29 pi over 18. So we have one answer is right here. Here's 2 answers, 3 answers when you have pi over 3. So pi over 3 gives you all these 3 answers. Now we have to do the same thing for this one. Gotta work it, take your time. So 3 theta, 3 times pi over 6 is pi over 2. Matter of just taking your time, making sure you don't make a mistake. Bring the pi over 2 over, make it positive. And we add them up. And so that's 6 is the denominator. That's a 4 pi. 6 is the denominator. That's a 3 pi. And now we have 3 theta equals, and that's 7 pi over 6. And we divide by 3, so theta is going to be 7 pi over 18. Divide by 3, we get 2 pi over 3. N belongs to the integers. So let's go with n is 1, n and 7 pi over 18 plus 2 pi over 3. So when n is 0, put a 0 here, we get 0, we get 7 pi over 18. We put n is 1, we get 7 pi over 18. N is 1 here, so we get 2 pi. And put n is 1, so we get 2 pi over 3. So that's 7 pi over 18. 18 multiplied by 6, I get a 12. 6, 2 times 6 is 12, so that makes it 19 pi over 18 when n is 1. And let's do when n is 2. N is 2, 7 pi over 18 plus, so we put a 2 here, so 2 times 2 pi over 3 gives me 4 pi over 3. So 7 pi over 18 plus 18 denominator. 6 times 4 is 24. So that gives us 31 pi over 18. 24 and 7 is 18. So we have that one and that one. And if we go again, we get, it'd be too much, be more than 2 pi. So the answers here, theta is, we got a 5 pi over 18, and we can go with the next one, but just want to do them in order, 7 pi over 18, and the next one is 17 pi over 18, and we got a 19 pi over 18, and we have a 29 pi over 18, and a 31 pi over 18. So notice the period here is 2 pi divided by 3. So the period is, there's 3 lots of them. So there's, you can see that there's 2 here, and there's 2 more, and then there's 2 more. So there's 6 of them altogether, because there's 3 times 3 cycles in there. when you draw your wave. So that's why there's 6 answers. Normally, if it was from 0 to 360, you would just get 2 answers. But now we got 3 times as much, so we got 6 answers. And that's, I wanted this one to be worked out to show you the workings of it in terms of, again, in terms of a radiant, and also in terms of manipulating these fractions. Okay, that brings us to the end of this video. If you like the video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.